Hi, this is Chris Kiefer, and welcome to the Power of ERDC podcast. Coastal engineers and scientists need to know the full range of sand grain sizes on various beaches to inform multiple applications, from designing protective structures to restoring storm-damaged beaches to beneficially using dredged sediment. However, collecting that information across our nation's beaches is difficult and labor-intensive. That's why ERDC launched SandSnap, a project to enlist citizen scientists to help build a database of sand grain size that will fill this critical knowledge gap and make our coastlines more resilient to storms. On this episode, we are joined by Dr. Brian McFall, a senior research coastal engineer at ERDC's Coastal and Hydraulics Laboratory, or CHL. Brian, it's good to have you.
Thanks, Chris. Great to be here.
And we also have Dr. David Young, a research civil engineer at CHL's Field Research Facility in Duck, North Carolina. David, welcome.
Thanks for having me here, Chris.
Yeah, absolutely. So both Brian and David have appeared on the podcast before, and it's great to have each of you back to discuss SandSnap and talk about the latest enhancements in version 2.0. And so I guess to kind of kick that off, and Brian, we'll start with you. Can you kind of give a quick overview of SandSnap and what it is?
Yeah, absolutely. So SandSnap's a really interesting project. It's the first project I've ever been involved in that's really tried to crowdsource data collection by engaging citizen scientists to go out to the beach. I'd say that when we started, we were one of the first and kind of premier Corps of Engineers citizen science initiatives, and I'd still say we're kind of on that leading edge, really, of any government agency. The idea is, we have a solid understanding of the waves that are impacting along our coastlines. We had a decent understanding of bathymetry and topography. So the elevation of our beaches and the shapes of our beaches, they're massive, large data sets that have all that information, but there was no universal beach grain size database. And so we said, that's a major knowledge gap, because, you can imagine if you have a beach made out of large cobbles versus really fine sand, which one do you think is going to withstand a big storm better? Obviously the big cobbles, because it takes more effort. But actually, even if you get down into sand grain sizes, there's coarser grain sizes and there's finer grain sizes, and that actually also influences how your beaches react. So when you try and do like a very large scale study, you could, without going out to the beach and actually collecting a physical sample and processing it, that we estimated that takes on average about $500 a sample. That from sending people out to the field, collecting the samples, and obviously they collect multiple ones. You wear and tear on the vehicle, fuel, take it back to the lab. We're looking at about $500 investment. And we said, there's got to be a smarter way to do this. And not only that, there's lots of different, beach managers and things that they would like to know how their beach grain size changes both seasonally, because your grain size can change by more than 300% seasonally, but it can also change by more than 300% whether you're at the swash, right where the water is running up and down, versus the dune. So these are, really interesting information about the grain size. It's really pertinent to understanding how our beaches are behaving and how they evolve. So our idea was, okay, could we send people out to the public, get the public to go out to the beach? They're already going to the beaches already. What's something they may already have on them? A coin, something small, so they could go to the beach, place a coin, snap a picture of the sand, upload it to the website, use your phone's GPS to record, here's where you are. It sends it up to our database, and within 2 minutes, it takes that image, processes it using different machine learning algorithms, and then it returns the grain size to the user. But most people don't really care, like, oh, well, your beach grain size is 0.25 millimeter. Like, okay, so what does that mean? So we also included a little fun fact about, your beach has the same gradation as the beach here where they filmed the movie Jaws, or here's a, famous beach where it's a great surfing beach. So we try and put like a little fun fact to kind of let them know, one, they're doing the right thing by, collecting the sample, but not only that, here's kind of another fun fact about a similar beach that has a similar grain size.
Yeah, sure. And hook on, and I think it's fascinating for people who don't spend their lifetime studying beaches and just their familiarity is just going to the beach, and that's how they know beaches. That there is a difference in grain sizes, and even within a beach. Like, in other words, if you go to beach A, whatever, beach in North Carolina, where David is, not all the sand is going to be the same. It's not like all the sand there is going to be, close to this size. There's a pretty big range.
Oh, yeah.
And kind of talk about, too, why knowing that does matter.
Yeah, so it's really interesting. So, well, one, it's really important to understand what grain sizes are there. And this is really pertinent to the Corps of Engineers because, well, we dredge sediment from our navigation channels. And we have a goal to beneficially use 70% of that sediment in a beneficial way. One of the most common ways to do it, particularly on the coastline, is to take that sediment and either place it on the beach or to place it in the create an artificial sandbar. In the near shore, I've created an artificial sandbar. Sometimes it's called littoral placement. Sometimes we call that a beach nearshore berm, or sometimes we call it nearshore placement. But basically, we're creating an artificial sandbar and letting that sediment be part of the beach profile and support the beach profile. Well, before we beneficially use sediment, most of our states have requirements that say, before you put sediment from that navigation channel on our beach, you need to show that it matches what's existing.
And that's so they don't inadvertently change the beach, the nature of the beach. Whatever.
Exactly. So different grain sizes will result in different slopes of the beach, which then reacts differently to the way the waves impact it and things like that. So it's important for them to understand what sediment is actually on their beach itself. So historically, a lot of times you'd have a project at a site and you'd go out and you collect a few samples and you'd say, okay, I took 3 samples and here's what the grain size is. But I kind of alluded to earlier that grain size changes seasonally. So a lot of times your beach, it's not a concrete beach. It's obviously dynamic. So wintertime, you tend to get bigger storms. You kind of erode it back. The beach gets more narrow, but that beach is still, that sand is still there. It's just submerged. Then summertime comes and the waves are a little smaller and it kind of slowly pushes that sand back up and widens your beach. So these actions are also changing your grain size. So the coarser stuff can withstand more wave energy and the finer sand grains are getting pulled down and they're getting pushed back up. So your grain size is changing significantly seasonally. So by having folks go out different seasons, different locations on the beach, even if you walk out on like a typical beautiful beach on, say, the Outer Banks of North Carolina where David lives, you can walk along the beach and you'll see pockets of, shell hash, and you can see different pockets of different coarser sediment versus finer sediment. And it's important to capture all that because if you only take a few samples and you say, well, here's the beach grain size, is that similar to what's in your navigation channel? Well, seasonally, you should have a larger range. And by getting folks to go out regularly and taking lots of samples, it gives us an opportunity to capture both spatially along the beach, the different grain sizes that appear, and also temporally. So like different seasons and different times. Before a storm or after a storm, you can really see some major grain size changes, which excites me. But most people are like, okay, so it changed. They're like, yeah, isn't that fascinating? It's one more thing to consider, isn't it? But it's one of those random things that get me pumped up.
Yeah. So in terms of beneficial use of dredged sediment, I guess by having this database, it enables more locations where you can place sediment because maybe you didn't know that there was a matching sediment, but now by having the range available through SandSnap, it opens more possibilities.
Absolutely. And a lot of times when we're beneficially using that dredged sediment, we're saying, hey, we have the sediment, we want to place it right here. And a lot of times folks go, well, I don't know that really matches. And I'm a little concerned that it's coming out of that navigation channel. But in reality, I think we've all been on the beach, swimming out in the water, and then you look up an hour later and your beach towel is, 100, 200 meters, 200 yards down the beach. And there was that longshore current that was slowly just pushing you along. You're just slowly migrating along. Well, it does the exact same thing to the sand. So it's migrating that sand along the beach profile. And then if we have a navigation channel, it'll fall into the navigation channel. So the logical place to do when you pull the sediment up and dredge it up is to place it down drift. So that way it continues migrating along the shoreline to the way it naturally would have. But by having a large SandSnap grain size database, it gives us the full range. So when people get concerned, like, well, I don't know if that sediment matches what's existing, it's like that sediment was exactly going towards your beach already. We're just keeping the sediment continuum flowing.
Sure, and now you can make a more informed decision.
Absolutely.
The database is there. And so from that, and as I mentioned, you've been on the podcast before to talk about SandSnap, and I think when I was looking at it the other day, maybe it's episode 18. If you kind of go way back in the log, people can listen to that and go more in details. But just again, at an overview of kind of how it started, why you decided to start in the first place, and kind of how it's evolved. And then I know as David is kind of sitting there patiently, I know he's been involved with some of those advancements that have happened recently, and I kind of want to have him talk about that in a minute.
Yeah, absolutely. So kind of the way it became to, I'll talk about how it got started. And then once we go into the real technical advancements, I'll talk about why I had to bring David in and all of his technical expertise.
Perfect.
The way it got started was I was working through the Engineering with Nature program on the International Natural and Nature-Based Features Guidelines. So this was a group that had, over 170 different authors from all these different countries around the world. We're trying to get together and say, what are some general guidelines for different features, that these nature-based solutions. And so there was a group that was working on, things like subaquatic vegetation. The other one was working on mangroves and reefs. And I was on the beach group, beaches and dunes. And as we talked through that, we wanted to create a new figure, and we wanted to show how the beach slope, the slope of the beach varies with grain size and wave exposure. And this is a known thing. There have been several other figures that have shown it, but nobody had ever put like an actual equation to these lines. And so I said, well, what if we tried to do that as a part of this project? And so I sent out an email. There's a group email chain called Coastal List, and it goes to people all over the world. And I said, hey, we're working on these guidelines. We're interested in getting grain size and slope information. And one of the people that reached back to me was Shelley Whitmire from James Madison University. And she's a professor over there. And she goes, hey, I have this really neat idea. I don't think it'll be sufficient for what you're doing for right now, but long term, I think we could get the public to go out to the beach. And she literally had this entire idea. She goes, we'll get the public, they can place a small object, maybe a coin, snap a picture of it, we process it, and then it'll be create this database of grain size information. And up to that point, there have been several times when colleagues had said, hey, I'm doing this massive, satellite scale analysis of the beaches on the Atlantic coastline. Do you have a grain size database? And we didn't. And nobody had one. It was this major knowledge gap.
Put together, yeah.
So it was always kind of in the back of my mind. So we had a couple programs that said, yeah, that's an interesting idea. We'll fund you a little bit of money just to investigate to see if it'll work. And so we started with this idea. We processed the grain size images this way, and then this way, and then this way. We went through several different methods. And then we pulled in David because some of these methods were getting more and more complicated. And David, I said, hey, he's a good friend of mine. We went to Georgia Tech together. He's very reliable when it comes to projects. When you say, hey, I have this wild idea, and he's like, hey, I'm in, let's do it.
Yeah.
So he jumped on board, and really a lot of the technical components, obviously never could have gone as far as we did without him. The other interesting part is that the other people that joined our team happened to be some of the world's leading experts. And it was like, here's this idea, what we're trying to do. And other world leading experts were going, I want to be part of that. So it kind of organically grew into this really interesting, technically capable team to develop SandSnap.
Yeah, and so talking about those developments, and I guess we're talking about version 2.0, in a sense now. David, kind of take us through that and take us through kind of how you've seen it evolve and some of the latest advancements that y'all are kind of rolling out.
Yeah, absolutely, Chris. So some of our big changes we have with the latest release of SandSnap. The first one is we have a lot more coin types that are available to throw down for your images. So when we first released SandSnap, you had to use a US-based coin. Now we can do Canadian dollars, Mexican pesos, euros, and what's the fourth one, Brian?
Pounds.
Oh, British pounds. Yes. So we can do a lot more coin types. That's one big improvement.
And I'll say real quick, the point of the coin is just a point of reference, for the size.
Right.
Mm-hmm.
Right. You can imagine, like, if you just take a picture of nothing but sand and you have nothing else to tell, like, it could be any size. You know what I mean? So it's there to convert the scale and give you a sense of how big that is in relation to some object that you know.
Sure.
And a coin's just a natural fit for that.
Mm-hmm.
So that's one big improvement. Another big improvement is we have added a lot of pre-screening models to basically check for things that are problematic. You might imagine we are asking strangers on the internet to send us photos, and sometimes it gets a little strange.
Sure.
And things that we don't want to be showing. So we have a machine learning model that its entire purpose is to say, did you attempt to take a SandSnap, or is this like a junk image? and it will filter that for us. It checks for some other things. Is there shell hash in this image? Is this image of gravel instead? In which case we might kick it over to CobbleSnap, which we're going to talk about probably later. Um, we also have a filter to check for if the image is extremely blurry. That one honestly is becoming less and less useful as cell phone technology is getting better. I don't know if you've seen like these latest versions of iPhones. Their deblurring algorithm is very powerful and can really clean up your images. But we still have that one in there. And the last thing is that of the different models we have available in line with SandSnap is we can automatically detect now what type of coin you put down from your image. We're still asking our users to send that to us because we're not 100% sure how well the model works, especially with some of these newer coin types that we've added. But that model is up and running. So those are our big changes that we have made to version 2 of SandSnap that are big improvements over what we've done so far.
Sure. I guess since this was launched, what, like 2021, 2022, around that time?
Somewhere around there, yeah.
So I guess since then, obviously, artificial intelligence, machine learning has really, taken on advanced, rapidly. Kind of how has that helped what y'all have been able to do? How much are y'all kind of leaning into some of those advancements?
Yeah, you're absolutely right, Chris. And even not even just since 2022, but even in just the last year,
Right.
we've just seen some really big changes. So more generic, these new LLMs, Claude, ChatGPT, Gemini, are very good at developing new software tools. So SandSnap is a software tool essentially, and it just speeds up the programming. I'm sure this is common to most like ERDC R&D type projects that involve coding in some language. Like LLMs can really speed up your development cycle and run tests on your new features, and SandSnap is no exception to that. More specific to SandSnap itself and the tools we have are the latest advances in image segmentation models. So image segmentation is just a model that looks for an object in an image or a movie. And they've come very far since we first started SandSnap. Where one of our big advances we're going to be putting into our next release of SandSnap is to use Segment Anything version 3. So Segment Anything is a image segmentation model that is publicly available. It's published by Meta. And Brian and I explored using the first version of Segment Anything a couple, maybe 2 or 3 years ago. And it worked well, but it was pretty brittle for our application. So we get a lot of different array of images, and it needs to be pretty robust to be able to handle the different images that we collect. And it just wasn't there. So sometimes it would give you really, really strong results. And then sometimes it would just struggle. And it was also quite slow. Fast forward to now, they've released Segment Anything version 2 and now version 3. And these models, not only are they very robust, they also operate zero shot, which means that you don't have to do any extra chaining to the model. Like like Meta's already trained it. They push down their GitHub. You just pull it down and it'll run for your applications. So Brian and I, we explored using Segment Anything version 2 just qualitatively to see if it would give us a big improvement over SAM 1. SAM is what they call the Segment Anything model, and it worked incredible. I mean, it was amazing at trying to identify things in your image that were not sand. So if you're looking for debris or shell hash or gravel, as it turns out, and it works incredible. And at this point, we turned it over to Gabe. So I don't know if we talk about Gabe.
I was just about to ask you. Yeah, so you're talking Gabe Monroe at GSL, at ERDC's Geotechnical and Structures Lab, has kind of helped you with some of this.
For sure. So one big advancement we made in the SandSnap team is it's now cross lab, and Gabe Monroe at GSL, he's a total rock star. Absolutely has been a huge asset for us and done a lot of development. So Brian and I, we contacted Gabe. It was just kind of a target of opportunity. He was looking to explore the civil work side. He does a lot of military work. His background is in developing simulated environments for automated robotic vehicles. And you might be thinking, what does that have to do with grain size analysis? How does it sound anything like it? It's actually a lot more similar than you might think, because it involves a lot of computer vision, machine learning. So you're using a computer to see something or define objects and images.
Yeah.
So it's a much better fit with the SandSnap squad than it first appears. And we reached out to Gabe. he took my very quick demo, like, hey, this qualitatively looks like it could be something with segment anything version 2, and built it into this entire workflow where it will, like, from a snapped image, you can now size larger sediment, so like gravel, cobbles, aggregate, things like that. He coded it all up. It runs great. The accuracy is great. And he's been a huge asset to the team. And I think we could even go into more detail on CobbleSnap if you would like.
Yeah, you keep giving me segues to it. I was going to ask you about next. Perfect. It's like we're on the same page here. CobbleSnap. So you've obviously mentioned it. Kind of tell us both what that is and why that matters.
Yeah, for sure. So Brian and I have, ever since we started SandSnap, we get asked very often if we can expand the range of sediment that you can take pictures of. So SandSnap only works on sand, so sediment that's in the sand regime, and it works great for a lot of beaches. A lot of beaches are comprised of mostly sand. Not all of them though. So some beaches are mixed sediments. That means some sand and some larger aggregate. Some can be like pebble or cobble beaches, like larger aggregate.
Yeah.
And so when we were initially exploring that first version of segment anything, that was what we were trying to do with it, was to see if it would work for something that would size these larger aggregate. And now with these latest releases, it's now possible, and we call it CobbleSnap. The tool that Gabe has developed, we call that CobbleSnap, and it's going to allow us to do these larger size aggregates, and also these mixed sediment beaches where you have some sand and some larger material. So we're excited about that.
Are there also other applications for CobbleSnap besides beaches? Does that kind of allow you to do more inland waterways, rivers, lakes, etc., or even beyond that?
Yeah, for sure. So Brian might want to hop in and talk about Helene, because I think CobbleSnap was also developed in partnership with UCL, but I can also go straight to the other features, Brian, if you want me to.
Yeah, I tell you what, I'll go ahead and explain a little bit more about why we got into CobbleSnap as well. So we knew that these new segment anything models were coming out, and that everyone was saying, hey, these are getting better and better. So we wanted to test it. But then also at that exact same time, there was a group in the UK that got funded through their National Science Foundation equivalent over there. And they got this big project called #GravelBeach. Yeah. And one of the tasks, numerous tasks were in that proposal, but one of them was to create some type of web application where people would go to the beach and they would crowdsource, similar to what SandSnap is, but they wanted to do it for their gravel beaches. And so they said, okay, well, we're going to do that. And they got into it. Similar, people don't realize SandSnap, when we created, how many hurdles you run into, and they realized this is really hard, and we're having this problem and that problem. And they were going, well, do we want to keep pursuing it? And then they said, well, the Corps of Engineers, they're already creating, SandSnap. Why don't we, leverage what they're doing and kind of team up? And so they reached out and said, hey, we're interested in this topic. And we said, okay, well, that's great. And then you start talking about, what value can you bring, what value we can bring. And one of the things that Helene Birmingham from University College London said was, hey, I have all these sediment samples that are sand and gravel, and I have them already sieved. And that takes a lot of time and effort to go to the beach, collect these big samples, sieve them, and then actually have those results. And she said, I have hundreds of these, and I can take pictures of them and I can send them to you, because we can run the segment anything models on these images, and you could look at it and qualitatively go, yeah, that looks really good. You picked it all out. But quantitatively, to say this is the amount of error we're getting, are we getting 2% error? Are we getting 5% error? These are valuable things from like an engineering standpoint to understand your amount of error. And so she was able to provide a lot of validation data for us. So we're kind of working with them in the United Kingdom to provide us the validation data. We're processing it, we're using our workflow, and that's really given us an opportunity to really accelerate how quickly we're able to produce this CobbleSnap.
Yeah. And David, you were going to talk about other applications of CobbleSnap.
Yeah. So to return to the features, the reason why they want it is because they have a lot more cobble beaches in the UK.
Right.
But also you'll find a lot of mixed sediment beaches on lake shorelines and rivers.
Yeah.
We do have some sand samples from lakes and rivers in SandSnap. But again, you're more likely to run into some type of heterogeneous mixture or more like larger aggregate in rivers and along lakes. And we're hoping that, I think SandSnap, or not SandSnap, CobbleSnap will work quite well for those types of environments and give us some really good results. Apart from the more closely SandSnap adjacent, it also has some construction related applications. There's a lot of need to size aggregate. So if you're trying to build a jetty or a breakwater, you're trying to size riprap, which is something like you might put down to armor your whatever you're trying to armor from erosion control structures for rivers or training structures for rivers. You need to be able to size what type of, how big is the rock that you're placing down there, and the cobble snap method is directly transferable from the cobbles on a shoreline or a beach to a big barge full of rock aggregate that's being shipped to construct a whatever, a levee or a breakwater or something. So those are the big other applications it's going to let us pursue.
Yeah, sure. And another advancement I want to make sure we talk about too. We had a podcast also several episodes back on Sandhound, which basically is an autonomous robot that could kind of go along. I know you all had it up there, at the field research facility in Duck. Can walk along the beach and do various things, but one of the things that you all tested it with was SandSnap, and so I guess maybe the idea of being able to do SandSnap on an autonomous robot can maybe allow you to get more samples in different areas. Tell us a little bit the work with Sandhound, or maybe even more so, kind of what that can enable you guys to do in the future.
Yeah, absolutely. So Sandhound, as you said, it's a robotic. It's actually a robotic quadruped is what it's officially called. Most people just call it the robot dog because you were gonna, if you saw it, that's what it looks like. It has its 4 legs and it walks on the beach like a dog. It is a project that we're doing in collaboration with the University of Delaware and Art Trimbanis and Jacob Stacywicks. And as you mentioned, it has broader goals than just SandSnap. That's just how Brian and I got involved. It's basically a platform that you can bolt all kinds of sensors to do these full beach surveys. If you wanted to know a whole lot of information about your beach. So the Sandhound dog has an onboard LiDAR scanner. It has GPS located so it can automatically detect its path. You can run, as an aside, you can run the dog. Either you can drive it like your like remote control, or you can pre-program a route and just tell it to go do it, and it'll do it. So it's got, in addition to the LiDAR and the GPS, it has a 360-degree array of cameras. It has a special camera specifically for SandSnap. It has a time of flight sensor because we're not dropping coins every 10 feet when the dog takes a SandSnap.
Right.
We're just backing out to the scaling factor from the camera information and the time of flight sensor. And it also has a cone penetrometer on the tail of the dog, which you can use to tell how compact your sediment is. So, like you mentioned, we did a demo pilot project at the FRF back in it was last July. I'm pretty sure is when we did that. Yeah, it was last summer. And the dog did incredibly well. It was able to traverse very loose sediment up the dune. It was very impressive. We got a really cool data set, and our paper where we published the results from the dog and showed how well it could work actually just recently got accepted into coastal engineering, which we're quite excited about.
Yeah.
So that's Sandhound in a nutshell, and then I can also talk about the more specifics about what it lets you do.
Yeah,
that
please. What does it kind of what can the lesson you learn from that mean for SandSnap moving forward?
Yeah, absolutely. So there's a couple of things. So the reason for the dog itself is that a lot of times if you're going to do a beach survey like before a storm or in the immediate aftermath of a big storm, it can be dangerous to have people on the beach. There can be debris on the beach, debris in the water. You may have limited access to medical care due to issues with roads and things like that. And so if you wanted to do a pre-storm survey or a post-storm survey, it would be really great if we could just have this autonomous platform. We could take the dog, we just throw it out there. It does its pre-programmed route, and it can assess how badly is the beach damaged, how badly are the dunes damaged, how badly are the structures on the beach damaged. It can also assess the trafficability using the cone penetrometer. If emergency vehicles need to be on this beach, like will they be able to go, or are we going to be in trouble here? And it does all that without exposing a person to any degree of risk. Well, much less degree of risk, right? Because they just have to launch the dog. The specific improvements for SandSnap are, in order to integrate it onto the dog, our Jacob had to take what we have on the cloud and convert it to work on one of those little Orin Nanos, which are like a little small Linux onboard computer. They're real tiny, and streamline and optimize the code to run on a much less powerful graphics card in a very unique set of settings. And this is what is going to allow SandSnap to become more portable and be loaded directly onto your device. So right now, if you were to take a SandSnap or a CobbleSnap, it doesn't actually do any processing on your phone. It sends it to the cloud, and the cloud does the processing.
Yeah.
But we would be able to put it onto a phone or like a small tool or a little small camera and nano setup. We could just take that model and port it over to pretty much anywhere we want to have a smaller, more compact tool for whatever application we have in mind.
Sure. I guess we kind of start wrapping it up, but a couple of things I want to is, first of all, just for people to understand the scope of SandSnap. I mean, kind of tell us. So first thing is, someone's listening to this podcast. I want to help. I want to help this database. I want to send a SandSnap. How do they do it?
Okay, so first of all, anybody that goes to the beach during the summer, you have a vested interest in that beach. And it doesn't take much effort to actually take a SandSnap. If you Google the word SandSnap, and I'm going to clarify, SandSnap, not Snapchat. A lot of people Google Snapchat, especially older folks. It's Snapchat. Like, no, SandSnap. Yeah, it's a little bit different. But if you Google the word SandSnap, one of the first thing that pops up is the ArcGIS website.
And we'll have the link, I'll say real quick, in the show notes too. So if anyone, everyone listening, look in the show notes and they can find the link there as well. But
absolutely. So you just go to the SandSnap website, and there's a few different things. If you don't know how to take a SandSnap, there's instructions. There's like a little 2-minute video, or it's 100 seconds. And it has like some cheerleaders from James Madison University that explain how to do the SandSnap, and they high five and do backflips. It's a fun little video, but that can tell you how to do it. But all you have to do really is take a coin, find a smooth part on the beach, place the coin, snap a picture of the sand. The viewing area should be about the size, a little bit bigger than a business card. So it's a little bit more zoomed in than what you typically take of a regular photo. But you take that picture, you say, you go to it's like a Survey 123 website. So you just say, find my location, or you can drop a pin. You say, there's the coin I use. Here's where I am on the beach. And then you say, here's my image. And you click upload, and then it starts processing. And within 2 minutes, it turns around and says, here's your result. The people that like to do it, we found that in all of our outreach, there tends to be, initially we were telling anybody and everybody, but now we realize more targeted approaches to our marketing has been more beneficial. So like there are certain groups that are already citizen scientists going out to the beach to collect other pieces of information. Getting them to also take a SandSnap has been very useful.
Yeah.
A lot of universities that are going out to do other types of analysis of the beach itself, taking a coin and taking a SandSnap is very simple. So we've gotten a lot of samples from those types of users. There are also some even consulting engineers that say, hey, I'm doing a feasibility study on this beach. Let me just go ahead and drop a coin and take a couple of SandSnaps. And it's accurate enough to give me a good idea of what the grain size is here right now. So those are some of the super users that we have. But really anybody can go to the beach and do it. We've also created class lesson plans and science fair projects and things like that. And that's all on our website. So if you click on it, you can either upload and create a SandSnap. You can also look at our database on that website. And our database, we have about 5,000 SandSnap submissions from all over the world. About 70% of our SandSnaps are in the United States. And that's kind of where we wanted to focus on. But from the very beginning, people were taking them in other countries. That's why we had to expand our coin types, because they were coming with or without our permission, or with or without the correct coin type. Right. So we have SandSnaps now. I think it's around 65 different countries around the world. We have 5,000 submissions. We average about 5 or 6 SandSnaps per day over the last year. So we're getting, there's some nice super users, some folks that have worked it into their routine. I encourage anybody that's going to the beach, if you're going to go to the beach on a vacation, one of the number one things people say is, Brian, I came back from the beach. I was totally going to take a SandSnap, but I forgot a coin. So I encourage anybody listening to this or watching the video, take some coins right now, stick them in your suitcase. You don't even worry about packing those later. Do it right now. And then when you go on your beach vacation, you'll have the coins ready for you to rock and roll. and to take some sand snaps, because it's a really great project, and it allows more data. And the more data you have, the more information you have, the more educated decisions you can make in the future.
Sure, you're really helping your beach, helping its future, helping its resilience. and all that.
Absolutely.
Yeah.
Mhm.
So, and an important thing, and we mentioned it kind of a little bit earlier, but that grain size changes over time. So
Absolutely.
just because, hey, okay, I already took one at this beach, they're good, they don't need it anymore.
Mhm.
You need as many as you can get, as many different times a year.
Right.
There's not a too many for this beach.
Exactly. And if you think about how much effort does it take to store an image and a little bit of texturing, it's not much. So if it's actually an important beach that I'm really concerned about, or that I'm really interested in, I'll often take 2 or 3 sand snaps. I'll take one up at the dune, I'll take one kind of in the middle of the beach, I'll take one near the water line, just because I go, you know what, I know that grain size typically varies. Let me go ahead and just take a few of them, because by the time you take one sand snap, taking 3 really isn't that much more effort. So we're talking a few minutes of effort. It's kind of like when I give blood. I know I'm doing the right thing, and it's like it doesn't take too much effort to do it.
Sure. And then having it again over time, when you go back next year, do it again, and you can kind of see the change over.
Absolutely.
So, yeah, sure. In closing, anything else that we haven't covered? I know you've talked about several of your partners already, but if there's anything there, or just anything else that you guys want to make sure you mention.
I think the one key message I want to make sure folks know is to take action. A lot of times you hear this and go, oh yeah, SandSnap's interesting, or you hear about an interesting research project. This is different than other research projects in that it's not just a tool where, hey, look, ERDC's doing something cool. It's like, no, we're doing something cool, and you can be part of it. And we found that a lot of times the younger folks are the ones that are most excited about it. We're actually working with the Infinity Science Center down on the Mississippi coast. They're the official visitor center for the NASA Stennis Space Center. And we're creating a sand exhibit. And part of that is going to be about SandSnap. But in general, they get 50 to 100,000 visitors a year that stop there at that center. We want them all to become SandSnap, sand snappers. We want them all to be understand, here's how it is, how to do it, and here's a useful tool to use in the future. We also want them to understand, the Corps of Engineers and how much we dredge, how we use that sediment, how to beneficially use it. So, because I feel like the more educated you are, the more likely you are to actually, okay, I understand why this is useful, and now I'm actually going to do it more often. So I guess my key take-home message is, take action. Don't just hear this and go, oh, that's interesting. Next time you go to the beach, bring a coin and take a sand snap. If you don't want to do it, get your kids to do it, because honestly, I think kids taking photographs tend to be better than the parents in general. So yeah, that's my key message. Take-home message, please take action and take one next time you're at a beach.
Sure, perfect. David, any other thoughts or things you're kind of look for the future of SandSnap, or anything else that we hadn't covered?
Nope. I covered all my big things we have moving forward. I'm really excited to see where this goes, though.
Yeah, well, great. Well, thank y'all. Thanks again for all the effort you've put into this. Again, as you've talked about, this is a database that's going to make our nation's beaches stronger. And so, so appreciate all the work. Appreciate everyone who has taken SandSnap through the years. And as Brian said, we encourage all of you listening to make sure you do it. It's a pretty easy process. Put those coins right now in your vehicle and your bag as soon as you get home, so you'll have it. And then next time you're at the beach, go ahead and take a SandSnap. So thank y'all for joining us. Thanks our audience for joining us again today. We remind you to go to our website, poweroferdcpodcast.org, for a variety of resources. You can listen to the audio version of this podcast. You can see the video of this podcast. We'll also have additional resources, as well as a link to the SandSnap website. So you can just go there, and we'll have it all for you right there. So that's all we have for today, and we will see you next time.
Thanks, Chris.